Ciao friends and welcome to a new video from SQL BI. In this video we are going to talk about functions. User-defined functions finally arrived in DAX, and that's a really important update because if you have a code in your semantic model that needs to be repeated multiple times, you can now create one function and use it as a predefined functions. So when you have a complex model, when you have a lot of DAX code, you can just create a set of functions that will be used through the entire model. That greatly simplifies the creation of complex models. So we are going to first introduce function, then we take a brief look at daxlib.org, a website that we created specifically to share functions with the community. And then we look at the two important topics about functions, because, of course, as with any new feature, there is something to learn before using them. The functions, the parameter type, some shenanigans with the parameter types that you need to learn, and then the most important topic, the parameter passing mode. That's a relevant topic that you need to be familiar with before starting to author functions, because the chances of making bugs in your code, really nasty bugs that you don't want to fix, are quite high unless you understand the parameter passing mode. Anyway, that's enough for the introduction. Let's start writing some code together. First of all, how do you define a function and what is a function? A function is nothing but a piece of code with parameters that will be called multiple times in your code. Now, the feature is still in preview, so we are going to see a user interface and we don't know if it is going to be final or not, but this is what you can use as of today. You can define functions in a query and then the function will be existent only for the lifetime of the query, or you can define a function in the model. And the easiest way to create a function is to start with a query, because then in the query you will have the option of adding the function to the model. Let's take a look at that. Here I have a query already open, and I use the define statement, and then I define a function. In order to define a function, as you might guess, you need to start with define function. Then you provide the name of the function. This function is a very simple one. It just sums two numbers. Equals to the list of parameters of the function. This function accepts two parameters, a and b, and the code is just a plus b. So it takes two numbers and sums them together. You can immediately test the function inside your query by following with evaluate, then you call the function as if it were a regular DAX function, passing it the parameters. You run the code, and as you might guess, the result is just 30. There's nothing special here. Couple of words about parameters. You can further specify properties of parameters. There are two important properties. The data type of the parameters, which is just a hint and it's not all that relevant, even though there are details we are going to investigate. And then the parameter passing mode, much more important. The data type can be specified by using colon and then the data type. For example, in 64, that says a needs to be an integer, and the same for b. B can be an integer, b can be a decimal, b can be whatever data type you want. These are hints. It is not mandatory that the function is called with these hints, but they introduce automatic casting. If I execute, the result is still 30. The second and the most important specification is the parameter passing mode. That can be exp or val. X brings that you pass the expression, and then the function evaluates the expression multiple times if it uses the parameter multiple times. Val means that you are passing the parameter as a value. So evaluation happens first, and the value of the expression is passed down to the function. It is worth much more words, so we are going to talk about it later. Before moving further, how do you add the function to the model? Well, once the function is defined in the query, you can just click on Update Model, Add New Function. There's a warning, then we update the model. And now you see that here in the list of the semantic model, we also have function with some two numbers. The function is now in the model and can be used as if it were a predefined function. So I can just create a new measure. Let's create just a stupid measure to demonstrate how it works. Let's call it test. when I call my function sum2numbers, and then I can use a sum of sales quantity, not sales, current sales quantity, and I use just an expression, or I can use a measure or whatever, like the sales amount. Now, this function is a user-defined function. I just define it. There's a parenthesis that I don't want. Too few arguments. No, we do. Oh, the parenthesis needs to be here. Okay. Let's add it as a decimal. I use test in my code, and the number is not relevant, but you see it is different from the other one because I'm summing in test sales quantity with sales amount. As I said, this is a stupid function. It's just to show you that you can create and define functions. Once the function has been created, I can change it like I plus b plus a, and I can click on override function. This will override the function that is defined inside the model. As I said, this is the user interface as of now. It's likely to change. You can define function here, or you can use the Tyndall view. If you click on the Tyndall view, you take the function and you drop it here, you get the definition of the function as a Tyndall function. You can change the code here, apply the changes, and this will update the code. So you can use it to modify functions that are already there. The Tyndall view is also useful for daxlib.org. It's a website that we created with the intent of sharing libraries of functions that can be useful for everybody. If you just go to daxlib.org, this is of course in preview right now, you can just click on browse packages. For example, we have created a simple package to do conversions. You click on that, you can look at the code, and here you have all the code of the library, but you can just click on add to Power BI, copy the code. This will copy the Tyndall definition of the code. Then you go back to Power BI, paste the code, and here you have the entire library. Create or replace, then the set of functions, you just execute it, and all the library will be added to your Power BI model. If you are not interested in all the functions, of course, you can take only the functions that are useful for you. That's just in preview, it's the starting point. I hope we and other people will increase the number of functions that are available at daxlib.org. With all that said, let's go back to theory and let's talk about different types of data types and parameter passing mode. First of all, the data type. As I said, data type are hints. So it is not mandatory that you call this function passing an integer. You can pass a floating point, a string, or whatever, and the engine will perform automatic casting. For example, here I have defined this function sum2numbers. The parameters are an integer by value and an integer by value that produces a plus b. What happens if I pass a floating point? Well, if I pass 3.4 and 2.4, 3.4 and 2.4, they will be converted to an integer before being sent to the caller. So 3.4 will be converted to an integer, and that becomes a 3. 2.4 becomes a 2 because it will be converted again to an integer, and the sum will be 5. If I execute it, I get 5 as the result of the first expression. The second expression passes two strings, but again 3.4, 2.4 are converted to integers before being passed. So even though the sum is 5.8 that should be converted to 6, the result is just 5. That's not a problem, you just need to be aware of that. The data type casting happens before the function is called, and each argument is cast separately. With all that said, you can specify the data types that is useful for documentation, but it does not require you to enforce the data type. You can pass whatever you want, and DAX will make the conversion. The second part that is most important is the parameter passing mode. The parameter passing mode is more important because it changes the semantics of the function. It completely changes how the function is evaluated. There are two parameter passing modes, val and expr. Val stands for value, expr stands for expression. If you use val, it is like the engine defines variables to host the value of the expression that you pass and then uses those variables. The function receives the value of the expression. So if I define the function this way, and I call it passing sum of sales net price and sum of sales quantity, or whatever expression you want, the code being executed is likely to be similar to this. It's like you define a variable a that contains the first argument, a variable b containing the second argument, and then a plus b is computed. So a and b are the two arguments. The expression, well, this should be contain only one, a plus b, is computed. So you evaluate it passing whatever. These are evaluated in advance and then passed to the function. This has a very important meaning. It means that if you use the value of the argument multiple times inside your function, it will always lead to the same result. I can use a 1,000 times in my code, even changing the filter context or doing whatever update I want. The value is static. It does not change through the execution of the code. This is useful and is the default parameter passing mode, but it is not the only one. Because sometimes what you want to pass to a function is not a value. You want to pass to the function an expression and then make the function evaluate the expression. So for example, you might change the filter context and evaluate the expression multiple times. Let me show you an example. You use sum2numbers, you pass EXPR. Now this is the same function, but I'm using the expression. This function is simpler than the previous one because there are no variables. If you call it with two expressions, it will be converted into the two expressions being used. What is the meaning? Well, first of all, it might be executed multiple times, but second, the expression will be evaluated multiple times. As an expression, let's say that I have this function. I create a function, compute for red, that receives an expression and computes the expression forcing the color to be red. So my goal is that I'm a function, I received like sales amount, margin percentage, and I perform that calculation only for red products. I define it in this way, and then I use summarize column, and I summarize by brand, and I compute the sales amount, and then in red sales, I use compute for red sales amount. If I execute it now, it's going to produce the wrong result. Indeed, you execute it, and you see that the value of sales and red sales, they are totally identical. There are no differences. Why did it happen? Well, the reason is I'm using a val parameter. So when compute for red is being called, the engine first evaluates sales amount. That leads to one value, which is the very same as sales amount being computed here, because that's the same filter context. And then the value is passed down to compute for red. Compute for red receives a number, and it returns the very same number in a different filter context. But the number has already been computed, therefore the engine does not compute it again. And the change in the filter context for red has no effect on the result. If what you want to obtain is a different behavior, so the evaluation of the expression inside the function, then you should not use val, you should use EXPR. If I use EXPR, that is very different. If I use EXPR, then the expression sales amount is passed down to the function. The function does not receive a value, it receives an expression, and it will evaluate that expression for red. And if I execute it now, and I look at the result, now you see that the values are different. This is just the sales for red, the sales for Southeast region, the sales for red and Southeast region, and so on. So it is important to define whether you want to use an expression or a value. The default is value because it's the most common one, but several times you will need to use expressions. Otherwise, well, you will have bugs and problems, and these are kind of complicated to solve. Let me go further and show you another example of a slightly more complex and interesting function. Here it is. Let's take a look at the function first, and then we see why it works and how we need to take care of some details. I want to create a function, best customers. Now, best customers receives only the best customers based on some metric. The metric that I receive is an expression like the sales amount. And I define a customer to be best if the value of this metric is larger than the average of all the other customers. So what does my function do? It first computes the average by iterating over the customer and computing the metric expression. So that produces the average of whatever expression I receive. Then I need to find those customers, and I filter the customer, computing again the metric expression and comparing it with the average metric. This produces a table that I can return straight, because I forgot to mention functions can return scalar values, but they can return tables as well, and that makes them extremely flexible and useful. So this function works, and I can evaluate best customers based on the sales amount. I run it, and I obtain as a result the list of customers who are the best customer. There should be around 1,000 of those customers. Let me check. Yes, we do have around 1,000 customers out of 3,000 customers we have in the entire model. It is important that we use EXPR here, because if we use val, so we receive the metric expression as a value and I run it, you see the result is empty. I have no customers that satisfy the condition. Why did it happen? Well, because now what I receive is not the expression, I receive the value. So the engine computes here the sales amount that leads to some number, whatever that number is. I pass it down to the function that computes the average over the customer of that number. And now the average of 3,000 identical values is the value itself. And then I filter the customer, checking whether the value is strictly greater than, again, the value itself. That produces an empty result. So using the correct argument is important, because if you don't use EXPR, that is not going to work nicely. Another important detail when you write functions is that functions are expected to be called by multiple measures, multiple places. So you need to take care of some details in order to make the function work seamlessly in any scenario. For example, instead of using sales amount, I can use sum x over sales of sales quantity times sales net price. What did I do? Well, rather than using the measure, I just expanded the code of the measure. And remember, I'm still receiving the metric by expression. What would you expect if you run this code? Will it work or not? Take a few seconds, look at the code and try to answer before moving further, because you put it in pause now, think about it, and the answer is coming very, very quickly. Did you do that? Did you put it in pause? Well, I don't really trust you. However, if I run the code now, the result is empty, even though I use an expression parameter. How comes the result is empty? Well, I'm using an expression, and that expression is being used here, and it is being used here. But the thing is, parameters are not like measures. When you use a measure, there is always an automatic calculate around the measure that forces the context transition so that the expression will be computed only for the currently iterated customer. That is because of the context transition, and the context transition comes from the fact that I'm using a measure. So when I was passing a measure, the context transition was happening. Now that I'm passing an expression, there's no calculate anywhere. Therefore, this average x is iterating over customer, but then it's computing that sum x without the context transition. So again, we are in the scenario we had before. The same number will be computed again and again, producing an empty result. You can make this work by manually adding calculate here. So you can add the calculate, and adding calculate forces the context transition here and here. And if I run it now, I get again my correct result. However, writing code this way forces the developers that will use the function to know in advance that they need to use calculate. That is not really fair. When you develop a function, you need to pay attention to these details and make sure that if you need the context transition, you use it. So the best way to define it is to use exp, of course, and because we want the context transition here, we use calculate inside the function, both here and here. So what I'm doing, I'm fixing the code in the function so that the users that use my function, they do not need to worry about adding calculate if it is needed. And if I run the code now, I get again the correct result. When you author functions, you need to pay attention and be a wise developer, a developer that makes the life of their users much, much easier. The second point that is worth mentioning is that functions are expected to work and be called by multiple places. So it is worth spending some time optimizing the code, making sure that the code is the best possible, because in that way, all the times that you will call the function, you will benefit from the optimization. Therefore, the best way to write the best customer is not to write it as we did, but to do it in a different way. We receive still the metric as an expression. Then we use add column, we iterate over customer, we consolidate in a calculated column, in a temporary calculated column, the value of the metric, and then from this moment on, we compute the average by using the value already computed, and we filter out of the table we already computed, checking whether the metric is greater or less than the average metric. This code is faster, better, it works more nicely, and it is a good addition as a function. So writing function requires you to understand the parameter passing mode and spend a bit more time caring about details and optimizations. As you have seen, functions are really welcome in DAX. I don't know how complicated, how large your model is, but the larger your model is, the more benefit you will have from functions, because you will have the option of creating your own library of functions and use them in different semantic models or in different measures inside the same semantic model. They are extremely useful, for example, to create functions that return tables that will be used as calculate filters. You have a complex filter, you consolidate it in a function. You have a complex filter, you can also create a function that receives the measure as an expression and checks the filter context. A lot of time people have been using calculation groups to consolidate code in a single place. Now you have function, and that will make your life with DAX much, much better. Enjoy DAX!